Welcome back to my channel. Today's LeetCode DCC question is diameter of a binary tree. So what question is saying, given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. Let's take this example and understand. So we can see the possible pair of nodes are in this tree, the possible pair of nodes are this. Now let's find the path between these nodes. So path between the length of the path between 1 and 2 is 1 since we have only one edge between them. So its value is 1. The length of the path between 1 and 3 is also 1. The length of the path between node 1 and 4 is 2 since we have two edges. The length of the path between node 1 and 5 is also 2 since we have two edges. Mm. Length of the path between 2 and 3 is 1 plus 1, 2. Now length of the path between 2 and 4 is one edge, that is 1. Length of the path between two nodes 2 and 5 is also 1. And the length of path between 3 and 4. 3 and 4 is 1 plus 1 plus 1, 3 edges. So value will be 3. And length of path between 3 and 5 is 1 plus 1 plus 1, also 3. And the length of path between 4 and 5. 4 and 5 is 1. The path is like this. 4 and 5 is also 2. Now, among all the pairs of the nodes, we have to return the longest path. So longest paths are 3 to 4 and 3 to 5, and the value is 3. So we have to return 3 in this case. So how to identify the longest path? So let's take this example. So in this example, we will see for any pair of nodes and the path between them, there must be a lowest common ancestor to whom it is connected. For example, if we want to find a path between 4 and 5, we can see the lowest common ancestor for 4 and 5 is 2. That means the path must pass through this node 2. And for 3 and 5, the lowest common ancestor is 1. That means this path, the path between 3 and 5 must pass through this node 1. In this way, we can see for all the pair of nodes, there must be a lowest common ancestor through which this path is formed. For example, 1 and 2. So for 1 and 2, the lowest common ancestor is 1 and past must contain this node 1. So in this way, we can say that for any pair of nodes, if there is a path, there must contain any one lowest common ancestor. Suppose there are many pair of nodes for whose the path contains 1 as the lowest common ancestor. So suppose there are 4 paths, 4 pair of nodes for which the lowest common ancestor is 1. Right? Now in this, which one will give us the highest length? Which one will give us the highest length? If we see only one, then can we say the highest length will be that pair of nodes which which is at the farthest distance in the left subtree of this node, and which is farthest distant at the right subtree of this node. So in this way, in the right side, we will go deep, deep and find the node which is at the farthest distance. And in the left subtree also, we will go deep and find the nodes at the farthest distance. Or we can say that node. So in this way, we will add this node's height, this farthest distance node height in the left subtree as well as in the right subtree. That will give us the maximum length which contains 1 as the lowest common ancestor. So that we have talked about 1. So in this manner, can we say we can traverse this tree and find the highest length for each node as the lowest common ancestor. Suppose we talk about only 5. So only for 5. So what is the maximum length which will give us the which between a pair of nodes which contains 5 as the lowest common ancestor? So for 5 we can see in the left subtree the maximum height of any node is 0, and as well as in the right subtree it is 0. That means the maximum length of any pair of nodes which contains 5 as the lowest common ancestor is 0. In the same manner, let's erase this. In the same manner, let's take 4 as the lowest common ancestor. If 4 is our lowest common ancestor, then in the left subtree of 4, we will find the maximum height of any node. The maximum height of any node is 0 in the left subtree, as well as in the right subtree, the maximum height of any node is 0. That means if the maximum length of any pair of nodes which contain 4 as the lowest common ancestor is also 0. So we have seen for 4 it is 0, for 5 also it is 0. Now let's take 2. So for 2 as the lowest common ancestor, we will see the maximum height in the left subtree. So in the left subtree, the maximum height of a node is 1. So in the left subtree, the maximum height of a node is 1. And in the right subtree, the maximum height is also 1. That means the maximum length of any pair of nodes between any pair of nodes whose lowest common ancestor is 2 is LST plus RST, that is 2. That means if we take 2 as the lowest common ancestor, then the maximum length between any pair of nodes will be 2. Now, let's take 3 3 as a lowest common ancestor. If 3 is our lowest common ancestor, then in the left subtree of 3, we can see the maximum height of any nodes is 0. In the right subtree also of root node of node 3, the maximum height is 0. That means for any pair of nodes which contains 3 as the lowest common ancestor, the length will be 0. That means for 3 also it is 0. Now we will see 1. So 1 as the lowest common ancestor, we will see in the left subtree of 1, what is the maximum height of any nodes. In this we can see this is 1 and 2, 1 and 2. That means the maximum height is 2. So in the left subtree, the maximum height is true. And in the right subtree of 1, in the right subtree of 1, it is 1. That means maximum length of any pair of nodes in a tree which have 1 as the lowest common ancestor will be 2 plus 1, 3. So for 1, it is 3. So out of all this, we have to find the maximum, which is 3. So this will be our answer. So for this example, 3 is the answer and we got 3. So basically what we have to do, so for any example, for any tree, we will find for every node as a lowest common ancestor, we will find the maximum depth for every node, for every node, what we will do, for every node as a lowest common ancestor, we will find maximum depth in the left subtree and maximum depth in the right subtree. So we will add the maximum depth of left subtree and right subtree. So this will give us the maximum length. This will give us the maximum length of a node, maximum length of any pair of nodes which have that node, that particular node as a lowest common ancestor. So we will repeat these steps for every node and out of every node. So we will repeat these steps for every node and out of that we will find out the maximum. So if we do a, we can do any, if we do a pre-order traversal or anything, so we can see if we find the height of a maximum depth for this node, suppose for this node, if we find the maximum depth is 0, then we can pass this value to its parent and we can say for this parent, the maximum depth at the left subtree will be 0 plus 1. Similarly, if the maximum depth of this 5 node is 0, then can we pass this value to its parents and we can say the maximum depth at the right subtree for 2 it will be 0 plus 1, that is 1. Now among this, whichever will be maximum, can we pass this value to its parent? So maximum of this 1 and 1 is 1, so we can pass this 1 value to its parent and we can say the maximum depth of the left subtree of this node will be 1 plus 1, 2. Similarly, for 3, we can see there is no children. That means maximum depth for 3 is 0. We can pass this value to its parents and we can say the maximum depth of the right subtree for 1 will be 0 plus 1, 0 plus 1, that is 1. So in this way, for every node, we can get the height depth of the left subtree and right subtree from its children. So in this way, we can find the depth for each node and we can get the maximum and we will return that. So let's try to code. So we will create a function that will give us the maximum depth of, of a node. So in this, if this root value is null, that means the depth of that tree is 0. Else we will find the depth of the left subtree, maximum depth of left subtree and maximum depth of right subtree. So once we get the maximum depth of the left subtree and right subtree, so we will find the diameter. We will update the diameter with the current diameter and with the maximum diameter. So if the existing value is maximum, then we will keep that as the value, else we will update with this value, right subtree. And then we will return the maximum of the left and right subtree to its parent tree, maximum of left and right subtree to its parent. So we will keep a global variable diameter to store the result. So in this diameter field, we will keep the maximum value. So initially diameter value is 0. So we will call this maximum depth function with the root node. And after this function is call is completed, we will return the diameter. So if the root node is null, that means the depth is 0. Else we will first find the depth of the left subtree and then the depth of the right subtree. Once we have the depth of both the left and right subtree, that means we have this depth as well as this depth, then we will update this global variable with this existing value or left plus right subtree. So here the depth was 2, here the depth is 1, so 2 plus 1, we will update the diameter and then we will return to its parents. So what we are returning, suppose we are on this node. So in this node, the left subtree is 1, the depth of left subtree is 1, depth of right subtree is also 1. So we will return the maximum of this 1 and 1. The maximum of 1 and 1 is 1, 1 plus this edge, 1 plus 1, that is 2. That's what we are returning to its parent. So once this function call is completed, in the maximum length of any pair of nodes will be stored in this diameter field. So we will return that. Let's try to run this test cases. So since the test cases has been accepted, we will try to submit the solution. So we can see the solution is accepted and it beats 100% of the users. So I hope the solution is clear. Meet you in the next video. Thank you.